All right, welcome everybody to the Pythagorean Theorem, the most important theorem in all of geometry. Seriously. You probably had it before, but today we'll reintroduce you to it. We'll prove it. We'll work some examples. We'll talk about the converse of the Pythagorean Theorem and how to classify triangles based on the sides. You'll see when we get there for the examples. Okay, Pythagorean theorem. So it deals with right triangles, only right triangles. That's it. That's the only type of triangles you have for the Pythagorean theorem. It's right triangles. You probably know it as a squared plus b squared equals c squared, but keep in mind that's only true when a and b are the legs and c is the hypotenuse. Okay, so if those letters were switched around, it would not be a squared plus b squared equals c squared. But the way to remember it is leg squared plus leg squared equals hypotenuse squared. That'd be the best way to remember that. Okay, so you actually can prove it. It's a theorem. And so that's what I'll do next. What you see there in the diagram is a big square which has sides of a plus b. And you can see that in the corners of the big square you have right triangles. They're all congruent right triangles. Each of the right triangles has one leg of a and one leg of b. And it's the same as you go around the square. And they all the right triangles have a hypotenuse of c. And so you see an inside square here with the sides of c. Okay, so we're going to start with this statement right here. Let me draw that in there. Let's see. So this one right here. So we're talking about area now. So the area of the outer square minus the area of the triangles equals the area of the inner square. So I think you can see that from the diagram. And so we're going to write some expressions for these parts. So the outer square, remember, is just this area of a square is side times side, so it's a plus b times a plus b. And there I wrote it as a plus b quantity squared. Minus the triangles, well, there's 4 triangles, they're all congruent, so I'll just take 4 times the area of one of them. Well, the area of one triangle is 1/2 times its base times its height, so 1/2 times a times b. And then again, the 4 outside because there's 4 triangles. And that equals the area of the inside square, which is just c squared, c times c. Let's do some algebra. So if we square the binomial a plus b from algebra 1, we have a squared plus 2ab plus b squared. Now let's multiply 4 times the parentheses there, so that's 2ab equals to c squared. And then once you cross out the 2ab and the minus 2ab, you have a squared plus b squared equals c squared. So there's a proof of the Pythagorean theorem. That's not the only way to prove it. There's other ways to prove it. That's just one that I think everybody can understand. Okay, let's put the Pythagorean theorem to the test here. Let's actually use it. So again, we don't have a, b, and c here, but we know that the Pythagorean theorem is is leg squared plus leg squared equals hypotenuse squared. So we can just say that's 4 squared plus 6 squared is equal to x squared there. So we got 16 plus 36 is equal to x squared. And if this doesn't come out even, that's fine. We're going to write our answer in simplest radical form, which we did a little bit earlier. So if you add these two numbers, you get 52 is equal to x squared. So we know that then x is the square root of 52. Well, that's not simplified. That's not considered simplified. So we're going to have to simplify that radical like we did earlier. So we're going to find the greatest perfect square that goes into 56. And remember, the list of perfect squares are 1 squared. Does that go in? Yeah, 1 goes in, but it doesn't help us. Next perfect square is 4. Does 4 go into 56? Well, let's see. 56 divided by 4 goes in 14 times. Oops. What did I just do there? I went 52 there. Mistake. Correct that. Sorry about that. Okay, so we got to simplify the square root of 52. And does 4 go into 52? So 52 divided by 4 is 13. So it does. So we got the square root of 4 times the square root of 13. So remember, 4 times 13 is 52, and 4 is a perfect square, and so we can then simplify that radical to x equals 2 times the square root of 13, so that's considered simplest radical form. So x is 2 times the square root of 13. Okay, moving right along here to our next Pythagorean theorem problem. So we got to find x. Okay, so leg squared, so 5 squared plus the other leg squared, so it's going to be x minus 1 quantity squared equals hypotenuse squared. So there we go. We got some algebra there. The rest of it is algebra. So we got 25 plus, this is going to be x squared minus 2x plus 1 when you square out the binomial equals x squared. Okay, looks like we can drop x squared from both sides, so that's going to give us, let's drop those off. Subtract x squared from both sides. That's going to give us a negative 2x plus 26 is equal to 0. All right, so negative 2x is equal to negative 26. So x is going to have to be positive 13. And I think that's all they wanted, so x is 13 by the Pythagorean theorem. Okay, next part's going to be a handy little thing. Hopefully you'll remember some of these. These are called Pythagorean triples. Pythagorean triples are sides of a right triangle. So in every single case, I wrote six Pythagorean pairs, sets, I think, 6 sets of Pythagorean triples. There are 3 numbers that are sides of a right triangle. So for example, in the first one here, you have 3 squared plus 4 squared equals 5 squared. Here's 6 squared plus 8 squared equals 10 squared. 5 squared plus 12 squared equals 13 squared, and so on. 9 squared plus 12 squared equals 15 squared. You can check it out in your calculator. 8 squared plus 15 squared equals 17 squared, and 7 squared plus 24 squared equals 25 squared. You can verify all those in your calculator. They are Pythagorean triples. There's more than that. As a matter of fact, there's an infinite number of sets of Pythagorean triples. So my point is, if you know them, then you don't have to work out the Pythagorean theorem. If, for example, let's take this one right here. If you're given a triangle, a right triangle, let's say, in which you know 2 sides are 9 and 12. And your problem is, well, what's the hypotenuse? Well, you could just call that C and then work out 9 squared plus 12 squared equals C squared, and eventually you're going to get to 15. Or you could say, well, I know Pythagorean triples for that, 9, 12, and 15. If 2 legs are 9 and 12, hypotenuse is 15 because you know Pythagorean triples. So they're just shortcuts. That's all they are. So just so you know, maybe you can put those to use sometime. Okay, so yes, the Pythagorean theorem has a converse, which is true. And here it is. If the sum of the squares of 2 sides of a triangle is equal to the square of the third side, then the triangle is a right triangle. That's the exact converse of the Pythagorean theorem, where you switch the hypothesis and conclusion. Let's do an example with that. Show that the figure is a right triangle. So the Pythagorean theorem says if you take 11 squared plus 60 squared, does that equal, I'll put a question mark there, does that equal 61 squared? We can check it out. So 11 squared is 121. 60 squared is 3,600. Question mark, 61 squared. Let's do that on the calculator. 61 squared is 3,721. So notice when you add the 2 numbers on the left side, you get 3,721. So the answer to this is yes, that is a right triangle. Notice it did not have the right angle given because we weren't sure at that time whether that was a right triangle. So we've shown that that one side squared plus another side squared equals the third side squared, so that makes that a right triangle. So it's a yes or no. Okay, so the last thing we want to do in this lesson today is talk about Pythagorean inequalities. So we know from the previous screen that if a squared plus b squared equals c squared, then the triangle is right. We also have a way to prove that the triangle is obtuse just by knowing the sides, not even knowing the angles. Okay, so think about this. I want you to think about this. If a squared plus b squared is less than c squared, that means the triangle is going to be obtuse. Why is that? Because if this were an equal right here, if this sign were equal, then you'd see the triangle the way it looks right there. But if that's turned to a less than, that means, let's say the C has gotten bigger, that means that this triangle is going to be wider open because C just got bigger, and that makes this angle here, that makes this angle here obtuse. So if a squared plus b squared is less than c squared, then the triangle is obtuse. And finally, let's look at this, and then we'll do an example for that. If a squared plus b squared is greater than c squared, then the triangle is acute. So it's like the c side got smaller. So if the c side gets smaller, to where maybe it's just like from here instead of the way it was, then you've made an acute triangle, because this angle right here is now less than 90. Even though that looks obtuse there, but this they would all be less than 90. Okay, one example, and I think that's it. So you might remember when we classified triangles based on their angles, but there you were given angles. Here you're not given any angles. We're going to classify this triangle. We're going to tell whether it's acute, right, or obtuse based on the sides. So basically, we want to compare a squared plus b squared with c squared. So I'll put a little box there. That's going to be less than, equal than, or greater to than. And then depending on that, we'll call it acute, right, or obtuse. So all right, let's try it out. So a squared. Oops, I got a number for that now. 8 squared plus 11 squared, empty box, we don't know yet, 13 squared. Okay, let's put some numbers in there. So it's 64 plus 121, and this is 169. Oh, running out of space. Okay, well, I can fix that. Just give me some more space like that. Okay, so I'm going to add these two numbers on the left side. So we got 64 plus 121. That's 185. So you got 185 compared to 169. So that's obviously going to be greater than. So that tells us that a squared plus b squared is greater than c squared. So that means this triangle is acute. Based on that Pythagorean inequality. All right, there you have it. So just kind of a review of the lesson. The Pythagorean theorem is the most important theorem of all geometry. Just relates the sides of a right triangle. Leg squared plus leg squared equals hypotenuse squared. We also had Pythagorean triples, which were just three numbers that make up the sides of a right triangle. And so if you know them, sometimes you can shorten up your work. And then we had a way to classify triangles based on it, on the relationship of the sides. So if a squared plus b squared equals c squared, you have a right triangle. If a squared plus b squared is less than c squared, then you have an obtuse triangle. And if a squared plus b squared is greater than c squared, that means now you have an acute triangle. So there you go. You got two assignments posted, which will give you some practice on this most important theorem. So let's get some practice and enjoy.